This is the screencast for section 2.4, example 5, finding a normal line. A normal line is the line perpendicular to a tangent to a curve at a point. So we've already found tangent lines, now we're finding these lines that are perpendicular to that tangent and also go through the same point that the tangent did on the original curve. So the setup is exactly the same at first. I've got to find the slope of the tangent line first. So I did 1 comma f of 1 and 1 plus h comma f of 1 plus h, plugged in all my stuff, simplified, etc. Now this is the slope of the tangent line, which means the slope of the normal line, which is perpendicular, is going to be the opposite and reciprocal, so that will be positive 1/2. Now it's still going to go through the same point on the original curve, which was 1 comma 3. So I have y minus 3 equals 1/2 times x minus 1. And as you can see, I've already graphed these. So here's the normal, here's the tangent, and here's the original function. I found a pretty good window and then just hit zoom square so that I'd be able to see these looking like perpendicular lines. Otherwise, if the window's skewed, they don't really look perpendicular, and I want to make sure that I did this right. The now try problem is the second two parts of number 11. We started that earlier in example 3, so now we're going to finish it up here in example 5. We already know that the slope of the tangent to 1 over x minus 1 at x equals 2 is -1, and the equation of the tangent line is here. So now we need the equation of the normal line. Well, the slope of the normal line is the opposite and reciprocal, so this time +1. It's going to pass through the same exact point, but just have a different slope. So it's going to look the same. Y minus 1 equals, the slope is now going to be +1 times x minus 2. And then for part D, I've already graphed in y1 the original, in y2 the tangent that we found from the previous example 3, and then y3 our now normal line. Again, found a pretty good viewing window and then hit zoom square so they look perpendicular.